AP Cram, Calculus AB, Free Response Exam Review, Question 18, Differential Equation and Slope Intercept Formula. Okay, so consider the differential equation, dy dx is equivalent to 2x minus y. Find the values of the constants m and b for which y is equivalent to mx plus b is a solution to the differential equation. Okay, so this one might take a little longer than others in this series. I'll give you a moment to gather your thoughts, and for those of you who know what you're doing, write out your complete solution, and for those of you who don't, it's fine, the answer is on the way. Okay, so we know that if y is equivalent to mx plus b, all right, then dy dx is equivalent to m. That's because the slope is the change in the y value over the change in the x value, okay? So this is a good starting point for us. We're just going to write that out. If y is equivalent to mx plus b, then dy dx is equivalent to m. All right? Now from there, we can perform some substitution. 2x minus y is equivalent to m because m and dy dx are equivalent to each other. So that's our first substitution step. Now let's go ahead and substitute for y. What do you think we're going to substitute for y? That's right, you guessed it, mx plus b. Now let's just go ahead and do some algebraic manipulation. If we subtract m on both sides, on the right-hand side and the left-hand side, we're going to end up with 2x minus mx plus b minus m, okay? And at this point, what we can do is basically combine like terms. So we can go ahead and combine the 2x plus minus the mx minus b, because we went ahead and distributed the negative sign to these two. And what we can further do, let me show you what I'm talking about. So this is what we're going to do. 2x minus mx, and we distributed the negative sign to the mx. We're also going to distribute it to the b, so minus b, and then we have our minus m that we brought over. It's all equivalent to 0. Excuse the time lag in my attempt at writing this out. Now we can do something more with this. We can factor out an x, and that's going to leave us with negative 2 minus mx, and if we combine the mx plus b, we get, if we combine the negative b and negative m, we can have a negative m plus b. What we did here was we factored out the negative sign again, and just we can group these terms together, okay? So this is what we end up with. I know this is the part where the math is getting a little hairy. And now for a lot of you, what I'm about to do is going to make you feel really uncomfortable and throw you off a little bit more. But for a lot of you, it isn't. This is insider knowledge. And the only way you would know this technique is if you were taught it in class or if you had some sort of instructor to show you, okay? So we're told that m and b are constants. So the only variable here is x. And And we have an x on the left-hand side of this equation, but we don't have it on the right-hand side. So what we can assume is that there is an x over here, but its leading coefficient is 0. So that's what we're going to do. The leading coefficient of x on the right-hand side is 2 minus m, but since it's not existent over on the right-hand side, on the left-hand side, the leading coefficient for x is 2 minus m, but since x isn't present on the right-hand side, we know that this 2 minus m could also be equivalent to 0. This isn't a trick that a lot of people do for algebraic solutions. It's not comfortable for a lot of individuals, but just trust me on this one. If you are to encounter this type of situation on your exam, this is something that you can do, and it would be a legit step, okay? So we're just going to focus on this portion for right now. So if 2 minus m is equivalent to 0, that means m is equivalent to 2, okay? And now we can take things a little bit further. So we're left with, if we pretend that this is 0, we're left with m plus b on minus m plus b on the, what do you call this? The left-hand side. And again, if we distribute the negative sign to the m and the b, let me show you what I'm talking about. So we can distribute the negative sign to again to the m and the b, and we can set that equivalent to 0. We can't say what these are for sure. Well, we know what m is now, but we can kind of just maneuver our way into it. So negative m is also equivalent to b if we were to carry b over to the right-hand side. And since we know what m is,